Hey everybody, today I wanted to talk about absolute value and derivatives. So this was kind of a follow-up video from the previous video on absolute value with the whole metric spaces and all that. But today we're going to talk about it with derivatives. And in the next video on this kind of mini-series, we're going to talk about it with integrals. So yeah, there are some calculus applications that I want to discuss. So that's what we're going to do. So first, what's the derivative of the absolute value of x? So what I'm trying to find, so I have here the absolute value of x, right? What's its derivative? Well, at first glance, it's really hard to figure out. I mean, if you look at a graph, it's pretty easy. So let me actually put the graph like over here. So it's increasing there, and then, but it's decreasing on this side, right? It's decreasing down here and then increasing. And if this is just the absolute value of x, the plain old function, this has a slope of -1, and this has a slope of +1. So it's pretty easy. We basically solved it. It's more of a piecewise definition, right? So you could think of the derivative of the absolute value of x as more of a piecewise definition. So we have here it's 1, and I guess it's undefined if you have 0. Actually, let me do it from left to right. So we have -1 if x is less than 0. It's undefined, so I'll put an undefined if x is equal to 0, but it's 1 if x is greater than 0. So this is kind of our definition, but we don't really want a whole piecewise definition, we want a function, right? Because you don't really see derivatives as piecewise functions. So let's go back to our whole metric spaces thing. Let's think about the absolute value as a distance function, a metric, and we came up with some formulas, right, for 2D, 3D, n-dimensional, that kind of stuff. Now we're just going to talk about one-dimensional, and there's only one dimension to talk about, so this is going to be equal to the square root of x squared. I made that very thin, but yeah, this is the square root of x squared. Let me just rewrite that. And you might be like, okay, well, isn't that just equal to x, not the absolute value? Well, not quite, because if you plug in a positive number for x, so let's say 5, 5 squared is 25, square root of 25 is 5 again, so that's fine. But if you plug in a negative number, let's say -5, -5 squared is 25, positive 25, and then the square root of that is just 5. So you'll always get a positive output, so that's why it's the square root function. Okay, so we can turn this into x to the x squared to the 1/2, right? That's what the square root means. So you might be tempted to just cancel these guys out, but don't, because then you're just going to be making the mistake of going back and saying it's equal to x. This is a lot easier to differentiate, right? We can use the chain rule. So let's say that the derivative of the absolute value is equal to the derivative of x squared to the 1/2, and this is equal to 1/2. We can move that 1/2 first. 1/2 times the inside to the -1/2 times the derivative of the inside, which is 2x, right? So we can do 1/2, we can cancel this 1/2 and the 2 out, alright? And now we have x squared to the -1/2. Well, that negative exponent means we put it on the bottom. And this x on the top, actually, so first we have this 1 over x squared to the 1/2, right? That's what that part is. And we have that x, which I'll just put it up here. Okay. This is easy because we can see x squared to the 1/2, which is just this guy, is equal to absolute value of x. So in the end, we get x over absolute value of x. And this is precisely the same thing as this. It's close to the signum function or sine, not S-I-N-E, but SGN. The only difference between this one and SGN is that at 0, x equals 0. So if x equals 0, like there's a point defined at 0, 0, pretty much. So what this function looks like, what this guy, I don't really care about the SGN guy, because he doesn't really matter. But so if we graph this, So for positive values, let's say 5 again, so 5 over the square root of 5 over the absolute value of 5, it's just going to give us 1, right? So for positive numbers, we just get 1. We'll say 1 there. At 0, we're undefined because we're dividing by 0. We can't do that, so we're undefined here. For negative numbers, it's negative 5 over absolute value of negative 5. That's going to give us negative 1. So again, undefined at 0, but we go this way on a horizontal line at negative 1. And that's what it looks like, and this is the derivative of absolute value. So that's pretty cool. Well, now what I want to say is, if we're dealing with motion, right, we know that the derivative of position is velocity and derivative of velocity is acceleration, but what is the derivative of speed? So first let's define some things. So if we say x, v, s, and a, s equals absolute value v. Speed is just absolute value of velocity. It doesn't care if you're going this way or that way, your speed is going to be the same. Your velocity is going to be different, but your speed will stay the same whether you're going left or right, right? So acceleration is just the derivative of velocity. So we know that dv over dt is equal to a. But what is ds over dt equal to? So what is ds over dt? So we're taking the derivative of speed, and we know speed is just absolute value of velocity. So we can apply what we learned, because what we're trying to find is the derivative of the absolute value of velocity. And I'll write it as v of t, right? Since we're actually formally doing this now, right? So the derivative of the absolute value of velocity, well, let's just apply what we've done. So first, we can say, well, first we're going to have this guy. So we're going to have v of t over the absolute value of v of t. But by the chain rule, then we need to multiply by the derivative of the inside, v prime of t, which we know is just a, right? So times a of t. And this, we can simplify it for ourselves. This is velocity times acceleration over the absolute value of velocity. So this is interesting because now we have a few different cases, right? So first off, if our velocity is positive and our acceleration is positive, velocity is positive but our acceleration is negative, velocity is negative but acceleration is positive, and velocity is negative and acceleration is negative, and then there are two more. So if our velocity is equal to 0, it doesn't matter at that point if acceleration is positive or negative, you'll see why, and acceleration is equal to 0. So these are our different cases, so like that. And now what I'm trying to find is, I'm trying to find ds over dt, right? The derivative of speed. Well, let's think about it. If we plug in numbers into this guy, so let me just box this guy, we're trying to plug numbers into him. So v, if v is positive, remember, positive over positive, that's just 1, so we'll get a, so for these two, it's just dependent on a. A is positive, right? So this guy is going to be positive, so I'll say ds over dt is positive. For this guy, ds over dt is negative. It's negative. For velocity is negative, remember, negative over absolute value of a negative is just negative 1, so we get negative a. So it's precisely going to be opposite of these. So ds over dt, if it's going to be opposite of this, so it's going to be less than 0. ds over dt here is going to be greater than 0. For velocity is equal to 0, we're dividing by 0, so it's undefined. But for a equals 0, we just get ds over dt equals 0. And yeah, so when we have these two guys both positive or both negative, then your derivative of speed is going to be positive. But if these guys are different signs, it's going to be negative. So you might see this in calculus and AP calculus, and this is why. You come up with this formula, which comes from this basically everything we've done here. So I hope this really helps you understand why it's like, oh, same signs, if velocity and acceleration are same signs, then your speed is positive, or your derivative of speed is positive. But if they're different signs, then derivative of speed is negative. I just wanted to make sure that you guys understood that. And again, derivative of speed is positive, just means your speed is increasing, and derivative of speed is negative, just means your speed is decreasing. So I hope you guys found this useful. Thanks for watching, and I'll see you in the next video. Bye, guys.